Now see here the working of the full wave rectifier. We have seen half wave rectifier. Now see here circuit diagram for the full wave here. Just I have taken here the coil, primary coil of the transformer, and here is a secondary coil of the transformer. It has got less number of turns, so that is actually here a step down transformer. There is a input AC, and here I am using here iron plates inside transformer. We can take here the two diodes, one is D1 and one I can take here as D2. These two diodes are connected across the load resistance RL. So, do not connect over here this load resistance, we can take in this manner, and now this here taken the load resistance, and this is your center tap, this is RL. So, we get output over here, and this point is known as center tap. Now, see what happened in this case. If we look at the graph, suppose I am taking here, this is the input graph in this way, this is the V and T, this is T here. I can draw here only output graph also here in this case. See here, when this positive terminal comes at this point, so this suppose P1 and P2, when the P1 is positive and P2 is negative. So, suppose when the first positive half cycle P1 is positive, then diode D1 conducts and D2 does not conduct because it is in the reverse bias, and current flows in the diode from this side, it comes to this side, and we can measure the output across RL, and that output will be like this. But here we can take now here again the V and T. In the next half cycle, negative half cycle, P1 will be negative but P2 will be positive. When the P2 is positive, diode D2 will conduct and D1 will not conduct. When the D1 will not conduct, current will be flowing like this, and again we can get output over here. And in the next half cycle again the D1 will conduct and D2 will not conduct. So, we will be getting output in this way. So, we are getting output in each and every half cycle of the the signal, but this output is a fluctuating output, but see here unidirectional. So, this fluctuating unidirectional output is known as here the direct voltage, but we can get constant output by using a filter circuit. We can say actually the output has got ripples because there are the AC and DC both components are found. So, we can remove the AC component by using capacitor or inductor, and then we can get the output as a steady voltage, and that is actually circuit used for getting this is known as filter circuit. Now, see here in this we have got the output voltage like this, which can be converted into a steady voltage by using filter circuit. So, let us see how does a filter circuit work and how do we make this voltage or fluctuating output as a steady output. So, now see the circuit diagram for the filter circuit. So, basically capacitor or inductor can be used, but we will be doing here that is the circuit which contains capacitor. Suppose you have got a rectifier over here, this is your rectifier. It gets signals from this side, it gives output to this side here, and here there are both the component AC and DC. Here we use a capacitor C, and here we use a load resistance RL, and we can get output over here. So, now see output voltage was actually in this type and we have to make it steady. How do we make it? So, see here when the rectifier gives the two components, because of the AC component this capacitor gets charged. So, first in the first half cycle it gets charged and across the capacitor resistance RL is connected. So, when it is fully charged to the peak value, it gets discharged also. If there is no RL, then there will be no discharging of the capacitor. So, capacitor gets discharged, and as capacitor again gets discharged, then again it keeps on charging in the next cycle. By this way we get output voltage approximately like this, in this way. So, here output voltage is here. So, with the help of the capacitor here, whenever the output voltage keeps on decreasing, then the capacitor starts discharging and it supports that one and it gives the current itself. Because of that, output voltage remains constant. So, with the help of this capacitor, and the value of capacitor should be chosen here, the larger value, to make the time constant larger here. So, this is actually the filter circuit, and by using the filter circuit we can get output voltage here in this manner.